Hydronic systems today. Hydronics is considered the best heat transfer machine. Large or small, the heat transfer medium used to carry the heat to or from an area depending on the needs of the structure. The versatility of a hydronic system is limited only by the imagination of the designer. Only a few basic fundamentals need to be mastered to do virtually anything with the heat transferability of circulating water in a hydronic system. Whether the system is the largest multi-building project supplied by a central mechanical plant or the smallest residence, these basic fundamentals still apply. We're going to talk about a few different types of systems in here. As you guys all know, we use chilled water and hot water all the time to heat and cool buildings, and what we're doing is we're just moving heat from one area to another. In the case of a heating loop, generating heat, circulating it throughout the building. In the case of a chilled water loop, picking up heat and moving it outside of the building. Something real old here that we get to start with is a gravity hot water system. It wasn't until the early 30s that pumps came into use, commonly for a heating system. Gravity hot water systems were in use before that, and if you know, when you heat water, it weighs less than cold water, and they used to use that weight differential to circulate hot water through a building. The drawbacks to that are, large piping sizes. That's pretty much why they don't use that anymore. That, and it doesn't work for a long, low building. You have to have a vertical building. So we won't worry too much about that. Hydronic boilers. Basically, hot water boilers are quite similar to steam boilers in the smaller sizes. Actually, many steam boilers are recommended by the manufacturer to be used for steam or hot water. The boiler is designed for hot water only. It should never be used for steam. The steam boiler must have some space above the water level for a volume of steam to collect. However, a steam boiler can be used to heat water because the entire system has water in it and no additional space is required. A boiler designed for hot water is more efficient than a steam boiler used for hot water. Modern hot water boilers are so efficient that a boiler large enough for a 6-room house may contain only 8 quarts of water. The advantage here is that the water heats quickly and doesn't hold heat when it's not needed. These types are available only to forced hot water systems, which have a circulating pump to force water through the system. Most small hot water boilers are sectional design. There's a picture of a hot water boiler on the next page. It talks about some of the parts used in there, the assembled sections, the jacket and insulation, oil burner or gas burner, combustion chamber, control carton, and a miscellaneous carton for hardware and other stuff. Electric hot water boilers, we'll run into those every now and then. There's 3 types of them. Conventional boiler with large internal volume, instantaneous type with a minimum internal volume, and the instantaneous type with wraparound electric heaters. Residential and small commercial model electric boilers are generally quite small and often mounted on the wall to save floor space. Some of the smaller models are designed to be mounted behind a thin tube enclosure. In addition to smoother, more positive operation, there are other advantages to be gained by using the manifold type of. Oops, I skipped an area there. Let's talk about the low water cutoff. Low water condition can occur in a hot water boiler. The record clearly indicates that most hot water boiler damage and boiler losses can be traced to low water. Essentially, the construction of a hot water boiler and a steam boiler is the same, as we said before. Most of the reasons why low water can occur in a steam boiler will also hold true for a hot water boiler. It's a common misconception that a pressure reducing valve used to fill a hot water system initially will keep the boiler and system full under all circumstances. But when it's realized that a pressure reducing valve is normally set at 12 or 18 pounds and a safety relief valve opens at 30 and closes at 26, it's pretty obvious that the pressure reducing valve is ineffective during the time that the relief is functioning. If a hand fill valve is used, then of course any leak in the system can quickly cause a low water condition. A few of the reasons why a hot water boiler can lose water so that the water condition, low water condition can result are listed below here. Losses of water due to carelessness, firing an empty boiler when it's been drained for layup in the summer, or drawing hot water from the boiler, leak in the distribution systems, pipes break or leaks in the boiler, leaks in the pump, relief valve discharge. Minimum basic controller should be installed on a hot water heating boiler as a float-operated low water fuel cutoff. And we tie into those quite often to give an alarm to the customer that the boiler is low on water. It's pretty important. And let's see, because of the higher work hot water. There's several locations that a low water cutoff can be used on a hot water boiler, but it has to be above the lowest water line that's safe. Let's see here.
What is typically a safe height?
Top of the tubes.
Okay.
That on a fire tube boiler. On a water tube boiler, I guess still top of the tubes.
Is there a picture?
Not really. It just kind of shows. I guess if you're real familiar with the boiler, it's kind of showing the front plate there, which would be where your tubes are, but it doesn't really show the tubes in it.
Turn back to page 317 and just look at that come out of the steel tube like line boiler.
There you go.
And then you set your water being above that.
Typically, well, on this particular one, this is a fire tube boiler, so the water circulates around the tubes. If you get below the tube level, it's pretty easy to crack a tube. Yeah, well, yeah, and like on an LES boiler, the tubes are vertical in it, and so they need to be full of water on the LES hot water boiler. So you'll see typically that the low water cutoff is clear at the top. There's another basic safety control means of stopping the automatic firing device if the water level drops below the minimum safe level. Final recommendation to cover all installations and provide the most complete measure of safety is to use a combination boiler water feeder and low water cutoff. Provides mechanical operation of feeding water to the boiler as fast as it is discharged through the relief valve. Electrical operation is stopping the burner when low water occurs. That way at least you're feeding water into it and you're not creating a bomb. There's several types of overfiring that can occur in which the operation of low water cutoff is rendered useless. In such an emergency, the only way the boiler can remain safe is to have water fed into it as fast as the water is being discharged through the relief valve. List of emergency conditions that can cause a feeder cutoff control to function and keep enough water in the boiler to maintain safety. Overfiring of a coal-fired boiler, we're probably not going to run into that. A fuel feed valve mechanically held in an open position that's stuck open. Burner system manually placed in the on position. Or the closing of zone controls isolating the boiler from the system with residual fuel bed in a coal-fired boiler. It shows in the pictures, overfiring happens. When overfiring happens, the feeder will maintain a minimum safe water level. When the water line in the boiler or system is lowered to the level of the feeder, the float in the feeder drops and opens the feed valve in the city water supply line. Or in some instances, it starts a feed water pump. Should a large leak develop, or should an attempt be made to fire the boiler without adequate water in it, the low water cutoff switch will prevent the burner operation. To be sure, every hot water boiler is equipped with the basic safety controls. Install an ASME type water relief valve to prevent overpressure in either a low water cutoff or preferably a feeder cutoff combination to guard against low water. You want to go through the questions? I don't think so.
I have a question for you.
Okay.
If you get low on water in your boiler, why doesn't the pump from the pressure the same?
Yeah.
Can you repeat that question long enough so everybody can hear it? I asked him, why is it that the bomb is because the water level in the boiler gets so low, the steam goes up and the pressure below?
That degrade your tubes.
Yeah, it'll degrade the tubes real fast if you are firing a boiler with no water in it.
How big is your boiler have to be before you need two low water cutoff?
What is this, 1930?
That's a good question, Bob. I don't know the
Yeah,
answer
clean
to
burning
that.
coal now,
There's a
you
certain
know, it's
size,
energy
because
efficient.
insurance companies are making all the bigger boilers have two cutoffs. One the float, one electronic. That's almost standard nowadays. If it's over a certain size, I think you do it.
And that must be BTU input on the burner side,
Right.
that's what it has to be.
But that's something to look for on older systems. If they don't have the second one on there, you should recommend we put it on that. If
It's always a good idea to have redundancy, especially when it comes to safety controls.
So when you run into that, have you put status on both of them?
Not status, they're just requiring cutoff.
I know, but a lot of times we'll put a status on the low water cutoff, you know. Going back
That's
to the
usually on the
others.
float, yeah.
You put it you just let it on the float?
You can tie it to either one. You can parallel
I've never heard of two going on the boiler, but I don't doubt what you're saying.
them. Most insurance companies
I've
are,
seen it
Yeah, I've seen it.
down at
I've seen it.
Beatrice on all their elementary schools, even they're smaller and they.
and I don't know if that's just Nebraska or just the insurance company, but over a certain size, you have to have two on there.
One thing when you guys are out in the field and doing PMs on a building, that especially if they don't have anybody doing mechanical PMs, it's always a good idea to blow down the low water cutoff and test its operation. I've seen plenty of times where the float gets worn, not the float itself, the linkage assembly gets worn, and it'll start hanging up and not letting the float drop, which will not let the, it won't cut off the boiler in a low water condition. And, you know, that can be pretty dangerous for the customer. So it's always a good idea to blow those down and make sure it cuts off the burner. and if it does have a feed valve or a feed water pump, to make sure that that operates also.
Especially if the customer doesn't use water treatment in the boiler.
Right.
Everything just.
Yeah, if a customer doesn't use water treatment in the boiler, especially like in a steam boiler, it'll create a calcium at the normal water level. And the calcium can build up around the float and not allow the float to move. Alrighty, should we go on to air and water systems? Most forced flow hot water heating systems are closed to the atmosphere and use a compression tank to handle the expansion of the water. That's something I didn't go over in the gravity feed, that water, not only does the specific weight change, but water expands when it's heated and contracts when it's cooled. So you need to have an expansion tank in your hot water system. You need to make sure that tank level is somewhere in the mid-range, not full, not empty. Some of the forced flow hot water heating systems are open and use an expansion tank as discussed in information sheet 47. Okay, well, I haven't run onto too many of those. I ran onto one where they were kind of using an expansion tank as an open tank, and getting the air in the hot water system caused the bottom of the expansion tank to rust. And when I tried to pressurize the system, blew out the bottom of the expansion tank. So you pretty much don't want an open system.
Now, Rick, are they nitrogen in them now, rather than, when we talk about...
No, a lot of them you see have a bladder in them rather than just an air cushion. And that's still typically just air in the tank. And they have a Schrader valve where you can set the air pressure in them. Typically they're pre-charged. I don't know that you can get one that's not pre-charged.
And so you're saying that will be separated, the air from the water by a bladder? Right?
Yeah.
But they do have those tanks that don't have the bladder, right? So,
Oh, most of them that you see out there don't have a bladder. Anything that's got any age on it at all. Most of the ones that do have a bladder are vertical tank. Most of the ones that don't have a bladder are horizontal tank with a gauge glass in the end. I guess they don't always have a gauge glass in the end, but they should.
How do you set the pressure on the top of the expansion tank?
Sure, what?
Are you talking one with a bladder or one without a bladder?
Yeah, either one.
Oh, one with a bladder, that's easy. Hook up an air compressor to it.
What pressure is it?
yeah, you got another...
The pressure depends on the height of the building, where the tank's located. Pardon me? Well, yeah.
Yeah, you got to figure that. How high is it?
But the system pressure varies depending on the building height and where you're looking at it in the system. It gets real fun to set the expansion tank level in a system where the expansion tank's in the basement and there's no isolating valves or anything, which there's not supposed to be an isolating valve between the system and the expansion tank. Typically you can isolate pumps or something to isolate that portion of the system, drain the tank down, allow air to fill the tank, and then typically when you put the tank back in operation, if you've drained it all the way and allowed it to fill up with air, it'll fill up to its proper level. And then I think further back in here, it'll talk more about air separators and expansion tank valves for setting the level. Closed hot water heating system holds a solid fill of water in the boiler, piping, and radiation. Water also fills a portion of the compression tank, and the remainder is filled with air. The air is trapped in the tank and, acting as a cushion or compressed spring, supplies pressure to all parts of the system. If this air is allowed to leave the tank and get into the system, it will immediately be apparent by the gurgling noises and piping. Radiation units will become airbound and will not heat. If the air is allowed out of the system with an automatic air vent or by manually venting the airbound heating unit, water will replace it. The compression tank will in time become waterlogged, and then every time the burner goes on and the water expands, the relief valve will discharge. Each time the burner goes off and the pressure in the system reduces, fresh water will be fed into the system, thereby causing corrosion over a period of time. All this can be avoided by correctly installing air control equipment. I did see one time somebody put a check valve in between the system and the expansion tank, and that created the same thing. Every time the boiler would complete its cycle, it would open the pressure relief valve in the boiler, and the boiler would cool down, the pressure would go down, and then the automatic fill valve would fill more water into the boiler and fire. At the end of its firing cycle, pressure relief would open, dump more water, and start the cycle over again. It was a pretty easy fix, just pull the guts out of the check valve. But I don't know why somebody put that in there. You know, why do people do anything they do that's not correct? You know.
And then fill valves get stuck, you know, same, you know.
Yeah, if the fill valve sticks open,
They get stuck on.
you know, it'll cause the pressure relief valve to open. It's typically a pressure relief you're going to see set about 30 pounds, and city water is typically around 60 pounds. So yeah, it'll never hold that. Shows a glass of water here. Illustrates graphically what happens in all hot water heating boilers. It's filled with tap water drawn at 50 degrees and left standing in a room until it reaches 70 degrees. As the temperature of the water increases, the bubbles grow larger. Capillary attraction will no longer hold them to the sides of the glass, so they will rise to the surface, break, and disappear in the surrounding atmosphere. Same thing happens in a hot water heating system, only there are more bubbles because there's more water. The bubbles are larger since the water is heated considerably above 70 degrees. It's impossible for bubbles to escape to the atmosphere in a closed system. If not controlled, the bubbles of air will travel through the system, causing gurgling noises and eventually become lodged in the radiation. As shown in the figure below, air can be trapped in the top of the boiler by using a dip tube. The boiler location is chosen for separating air from water because, number one, it's the highest temperature in the system, and number two, the velocity is the lowest. Water is heated in the boiler and gives up some of its air. The water then passes out into the system, cools, and absorbs any small bubbles of air which might be clinging to the top of the piping. This new air enters the boiler and is released from the water and rises to the top of the boiler. The air that's trapped in the top of the boiler must be directed into the compression tank rather than allowed to flow through the system. Air must never be completely eliminated from the system as required in the compression tank. Air control equipment consists of an airtight compression tank, a boiler fitting, and a tank fitting. As shown in figure 49-2, the dip tube takes water from the boiler below the area where the air is trapped. Operating cycles of the boiler cause changes of pressure in the system, and the compression tank is the cushion. During the on period of the burner, air bubbles from the top of the boiler pass around the dip tube, through the piping, and into the compression tank. Here the water cools and absorbs air. During the off period of the burner, the system pressure lowers and the water flows from the bottom of the tank to the top of the boiler. When this water reaches the higher temperature water in the boiler, the air in the solution is immediately released and again rises to the top of the boiler. This is a continuous cycle which occurs each time the boiler operates. You know, like we talked about, that the water expands when it's heated, contracts when it's cooled, and that's why you get flow between the compression tank and the boiler. Compression tank performs 4 important functions in a heating water system. It allows the water in the system to expand and contract as it heats and cools, while allowing slight fluctuations in system pressure. It maintains a constant minimum pressure on the system, making possible water temperatures up to 240 degrees, which result in reduced radiation sizes. 3, it acts as an automatic air receiver and collection point. And 4, it eliminates the need for the constant addition of water to the system. The cross-section of tank fitting installed in a compression tank in figure 49.2 down in the lower left corner shows the passageway for air and water with air bubbles rising into the tank. The burner's in the off cycle since the water is flowing from the tank back to the boiler. The central tube with the manually operated air vent at the bottom permits air to escape from the tank during the initial venting of the system.
Let me go back to my desk.
While free passage of air rising into the tank is necessary, some method of restricting gravity circulation between the tank and the system is needed. A form of check valve which allows the air to pass freely but will reduce the circulation of the system water is needed. This fitting should serve to reduce tank pressures or tank temperatures and thus reduce tank size considerably. The tank fittings in figure 49.2 and 49.3 serve this purpose. 49.2, that's pretty typical of what you're going to see in there. There's a vent tube that runs up the center of that valve, where when you loosen the fitting at the bottom, you can bleed air out of the tank, and it takes the air off of the top of the tank. And then it allows water to go around that tube. It's like a 1/8-inch tube inside of a 3/4-inch pipe. I have 2. That's when you need to replace them. Yeah, anytime if the water level's in the mid-range of the tank or lower, and you open the vent tube and water comes out, hey, you'll get a little spurt of water initially, but if water comes out, then you know that tube's rotted out and you need to replace the tank fitting. Boiler dip tubes. The most common and often one of the most effective air separators available in the conventional hot water heating boiler. In boilers having large internal water passages, water velocity is usually quite low, and free air is released in heating and can readily rise to a convenient high point. From this collecting point, air can then rise into the compression tank. To prevent free air collected at the top of the boiler from being circulated out into the system and into the radiation. Boiler dip tubes are installed. These dip tubes are either top outlet or side outlet, as shown in figure 49.4. Shows kind of a drawing. These are typically right at the top, at the outlet of the boiler. Some boiler manufacturers furnish these dip tubes as standard equipment. Boiler dip tubes should always be installed so that the adjustable dip tube is pushed into the boiler as far as possible, well below the top of a top outlet boiler or well into the side of a side outlet boiler. Air separators. Often, however, a boiler is not available or usable as a point of air separation. Another low velocity area must be provided in the system as the air separating point. Figure 49.5 shows an air separator that's used in a boiler converter and chiller installations, which cannot use the standard dip tube fitting. The air separator has a built-in dip tube and a reduced velocity area, which provides excellent air separation for all closed systems. Figure 49.6 illustrates an effective low-velocity air separating tank for larger systems, which is equipped with a dip tube to create a reversal of flow. Tests have shown that water velocity must be reduced to at least 6 inches per second for effective separation of free air from a piping circuit. However, a straight-through tank for air separation, even though sized for low water velocity, is apt to develop short-circuiting channels or water streams where the bubbles will remain entrained. The vertical distance and velocity of water travel in a separator is directly related to the percentage of free air that will be separated. The air separator also serves as an effective settling point for sediment and other debris common to new piping systems. These air separators, it's just a big volume tank to slow the velocity down, you know, and kind of let the air naturally separate from the water. The next one is probably one that you'll see more often, centrifugal air separators. The circulation in a centrifugal air separator causes a vortex or whirlpool in the center where entrained air, being lighter, can collect and rise into the compression tank installed above it. Instead of relying entirely on low velocity separation, the action of centrifugal force sends the heavier air-free water to the outer portions of the tank, allowing the lighter air and water mixture to move to the lower velocity center. An air collecting screen located in the vortex aids in the developing of the low velocity area in the center where air can collect. This air separator offers the advantage of achieving efficient separation in a much smaller sized tank. Cutaway view of the air separator shown in figure 49.7. This illustrates how the tangential flow pattern is established. The dish steel divider across the center directs water flow down into the center of the basket strainer before leaving the outlet. And they do show in the drawing that on these, with this style of air, actually with any style of the air separator, the compression tank will be connected to the air separator rather than connected above the boiler. The compression tank needs to be wherever the air is going to be eliminated from the system so that the air goes into the compression tank. I have also seen these, and I guess it shows it also in the fitting, that they sometimes, I guess it doesn't really show it, sometimes I've seen an automatic air vent on the top of an air separator where the expansion tank is in a different location, but they still allow air to vent from there. And then also makeup water is typically piped to where as the water comes in, any air in the water will go into the expansion tank. Air separation for multiple boilers. A single tank is generally not recommended for internal connection with multiple boilers. This is because a pressure difference between the boilers will cause a flow in the header connection. This flow prevents delivery of separated air to the compression tank as shown in 49.8-C. One way of solving this problem is to use a pump header connection through an air separator as illustrated. Oh, and they're showing how the air separator and compression tank needs to be remote mounted in multiple boilers, not mounted right to the top of the boilers. Okay, I guess we could probably move on to pumps. They're just talking about a couple of different styles of pumps here, low head pumps and high head pumps. Low head pumps are generally considered as pumps having a 0.5 horsepower motor or less and operating below 12 feet of head pressure head. Another definition, a low head pump is less than the static height of the system. These circulating pumps can be installed to pump either up or down, left or right, simply by separating the bearing assembly from the pump body and rotating the body until the arrow points in the direction of the water flow. And then reinstalled. None of the moving parts of the pump need to be altered to make this change. In addition, there's no limitations on the placement of the pump in relation to the boiler. Pump may be installed in the most convenient spot on either the supply or return piping. The return piping is the most common location. When choosing a location, see that the pump receives as much ventilation as possible and that it is accessible to facilitate easy servicing. You guys don't need to worry about that. You won't be installing any pumps. They're typically a low head pump. It's just a circulator. You may see it on a return pump for a domestic hot water system, or just for additional circulation. You should never see it as a main circulating pump. High head pumps are all pumps above a half horsepower and operating above 12 feet of head pressure. Or another definition would be a high head pump is one whose head is more than the static height of the system. Most people are familiar with water pumps applied to wells. If the suction lift is not too great and the water flows freely into the well, the pump runs smoothly for years. The water does not flow into the well fast enough to supply the pump. If the lift is too high or if the strainer is clogged, the pump is starved. The pump labors in its effort to discharge its full capacity and is finally damaged. In a hydronic system, high head pumps operate on exactly the same principle. Physical laws require that a free flow of water enters the suction side of the pump, equal in volume to the discharge capacity of the pump is starved, creating a partial vacuum on the suction side of the pump. When heated water is present, the partial vacuum produced, which lowers the boiling point of the water, it'll cause the water to boil or flash into steam. Pounding occurs in the piping and pump damage can result. Obviously, the way to prevent boiling or steam flash from occurring in a system, regardless of the temperature, is to maintain sufficient pressure at every point in the system. In top floor radiation and at the pump, particularly if it is a high head pump. You wouldn't see that. You wouldn't see flashing on a fractional horsepower pump very often. Flashing, something like that can occur either low water pressure in the system, plugged strainer, anything like that. And actually, when the water flashes into steam, it'll hit the impeller on the pump and ruin the pump. Pardon me?
It's like pumping gravel.
Pretty much. Figure 50-2 shows the proper installation for a high head pump. The pump is running out of the boiler, thus adding its pressure head to the radiation circuit. Notice that an automatic air vent should never be used on the suction side of a pump. For initial venting only, a manual vent will permit the proper filling of the system with water. And typically that's the way you'll see a pump pipe. It should always be on the leaving side of a boiler. You very rarely see a pump on the return side of the boiler, other than, like I was saying earlier, hot water return pump for a domestic system. And that would be probably a fractional horsepower pump, and all that's doing is creating flow so that there's hot water available at all the taps at all the outlets in the building all the time. Now we get to talk about compression tanks again. Maybe. Looks like it's pretty much everything that we've already talked about. Let's skip over to the reducing valve. Reducing valves shown in figure 50-5. Valves factory set to reduce city water pressure from the pressure in the main to 12 pounds per square inch. This adjustment is quite satisfactory for 1- and 2-story buildings. For 3-story or higher buildings, the adjustment should be changed accordingly. Should be a minimum of 4 psi in the highest radiation. To change the adjustment, just loosen the jam nut and turn the set screw in. Or turn it counterclockwise. That'll reduce the pressure setting. They talked about, most of them are set at 12 pounds. And that's fine, like they say, for a 3-story building. But becomes a challenge, I guess, when you get into taller buildings. I guess a lot of guys don't think about adjusting the pressure regulating valve for the building height. Was it
2.31 feet per pound PSI.
2.31 feet per pound?
Yeah,
Oh.
per PSI. So take the height of your building, divide it by 2.31, and that tells you the pressure. Plus, they want 4 or 5 at the top.
Right.
That's how you do that.
Okay, and then, that could cause poor circulation in the upper floors of the building if the reducing valve's set too low. Could cause splashing in the pump, especially if you've got your reducing valve set a little too low and a little bit of a restriction in a strainer, that type of thing. Strainers typically do not have blowdown valves on them. The only time they'll have a blowdown valve is if they've had a problem, typically. So I guess they're sometimes a little difficult to determine if you have a plugged strainer or not, unless you have gauges in the system where you can actually see pressure drop across the strainer.
How old is this picture gas for? This isn't accurate anymore, is it?
Our coal-fired boilers.
It's as old as you, Bob. Well, no.
Probably older than you, Bob.
The state code requires a backflow preventer.
Oh, it doesn't show a backflow preventer,
Yeah,
yeah.
that's why it's not really accurate.
Actually, it doesn't even show a check valve.
No.
Well, we're not plumbers, we don't need to worry about backflow preventers. Plumbers get to do those in Omaha. Actually, in Lincoln, I guess the fitters do get to do backflow preventers.
But if we're in a building, an old building especially, there's still buildings that don't have those, even though they're supposed to.
They're getting kind of few and far between these days.
Are they?
Yeah.
There's still some places. You should make the customer aware of that.
Oh, you definitely should always make the customer aware that they should have a backflow preventer.
Especially on a boiler system, that's the main. So you're not backing up to this water.
Well, yeah, any closed loop system, because any closed loop system should have water treatment in the system. And, there's a possibility with pumps and stuff that system pressure could be higher than city water pressure, especially in tall buildings. Yeah, I don't know about you, but I don't want to be drinking any water treatment.
That's happened in Omaha.
That's happened in Omaha?
Yeah, several buildings with the water treatment, the water fountains,
Yeah.
they start coming out pink water. And the boiler chemical is feeding back into the water system.
Everybody likes pink water, don't they? Okay, let's talk about flow control valve here a little bit. These valves are used primarily in residential and small commercial installations to prevent gravity circulation when the pump is off. To minimize installation problems and ensure proper operation, the valve size should be equal to the main size. These valves are supplied in either a straight or an angle pattern. The straight pattern is used and must be installed nearly level as possible. Similarly, the angle valve must be mounted on a truly vertical pipe. A good idea is to replace the first 90-degree elbow in the supply main with an angle pattern valve. If the system consists of more than one zone, a valve in the supply main and the return main of each zone is imperative to prevent flow in the zones where there's no call for heat. And we wouldn't have to deal with that much. Not like we're out there installing boilers, so not in residential systems anyway. Any questions on any of the stuff we've talked about here? Anybody still awake?
No.
Hey Rick,
Yeah.
if, what would be the proper way to get all the air out of a hot water system?
Are you talking an initial fill or?
Now, we come in to service a building, say in the fall. They just started the heating system up, and there's a ton of air in it. You want to just kind of step through what the normal steps are to get rid of all the air?
Well, typically start with the pumps off, go to the highest point of the building. Should be a manual air vent or an automatic air vent in the highest point of the building. That should eliminate most of the air. Some buildings out there don't have the greatest piping job, and you've got to go around to each individual radiator or coil or whatever you happen to have in that building and vent air from there. And then typically you're going to have to run the pumps for a little while and then stop and do it all over again. Like I said, that some buildings that have poor piping design, poor piping installation, you can be there for a long time, vent air, run the pump, stop the pump, vent the air, run the pump, stop the pump, vent the air. That's about the only way I know of getting air out of the system. That answer your question, Dan?
Yep. So a lot of people, I guess, don't realize that you need to shut the pump off to get the air out, so.
Yeah, that's true, because if you have the pump running, as the water's moving, it's going to pick up air and move it throughout the system. And not only that, your air is always going to be moving around the system unless you have the pump shut off. And doing it multiple times, the air will tend to collect in the highest points of the system. And should be able to get most of it out that way.
You need to make sure that they can water balance what water is there too.
Yeah, that's a good point.
Otherwise, it's going to be any good air.
Well, in between, a lot of times venting air from the system, an automatic makeup valve. If you're depending on an automatic makeup valve to make up water in the system, especially if you've been working on a system and or somebody has been working on the system and has drank quite a bit of water out of it, go up and vent air until air stops coming out. Go down, open the manual fill valve until you get to at least the operating pressure of the system. Typically, I always like to go a little higher than that because otherwise you're running up and down a lot. You know, especially if you've got a lot of air in your system. You know, even if the automatic makeup valve is open, it'll take forever. So you want to use the manual makeup valve.
Can you cheat and use that little air tool on the bottom of the expansion tank?
Let all the air out of the expansion tank.
Yeah.
Well, then you have to reset the expansion tank level when you fire up the boiler. You may notice also a lot of chilled water systems don't have any kind of an expansion tank, and that's because the water temperature doesn't fluctuate all that much. Typically, they're just on hot water systems. I don't really want to start on the hydronic, the loop piping stuff today. We only got about 5 minutes left. If nobody's got any more questions, I guess I'm done.
Hey, Dan?
Yeah.
Who's down in Lincoln?
Right.